right, hi all. So the next topic we're going to talk about is end behavior. And so if we're going to dissect the word end behavior, you are basically describing what is happening to your graph on both ends, meaning the right end and the left end. So I'm going to give you a generic definition. It describes your graph on both ends. And again, there are two ends of graph. There's a left end and then there's a right end. Okay, so what this is saying is that you're going to take a look at your graph, and so depending on where it goes, if it looks like this, or this, or this, or this, okay, different hand motions, you are going to describe what your hands are doing or what the arrows are doing. So is my arrow going up? Is my arrow going down? Is my arrow going to 1? Okay, so we're just going to do this of polynomial functions. And so you should know a polynomial by now is a smooth continuous function. So to remind you, a polynomial is smooth and continuous, right? So what that means is that you have arrows that either go up or go down or go up down or go down up, right? So those have been kind of the main functions that you've seen. These two have been even powered and these two have been odd powered, right? Arrows going in the same direction mean it's even degree. Opposite direction means odd degree. Okay, so now let's talk about this end behavior. So the generic statement, there is a statement that you write to talk about end behavior. So just like the original, the generic greeting, you would say, hi, my name is, right? That is very generic. That is what you usually do. So when you describe end behavior, it has a generic statement as the same. So our statement would say, as x goes to positive infinity, my function goes to, and then that's where you fill in the blank. Where in the heck does your function go to? Okay? So what this says is that as you are looking at your function to the right, what is the right arrow doing? So if I were to put this in quotes, the right arrow is going where? Okay, and so how do you say if it's going where? Well, you have to give a direction. Well, what are some directions? Well, it could be going to 1, it could be going to positive infinity, it could be going to negative infinity, it could be going to 0. It depends. Okay. Now this describes the right arrow. Now how would I describe the left arrow? So as x goes to negative infinity, my function goes to. Now this describes the left arrow is going. So you are explaining to someone what this graph looks like and what in the heck this graph is doing. Okay, so if I were to give you a quick, like, random example, not even on the graph. Okay, so let's draw a nice smooth curve. And so if I were to take a look at this function, this is my right arrow, and it is going to positive infinity. Okay? This one's my left arrow, and notice it is going down, and the direction of down is negative infinity. Okay? Now what about this function? So now this one's a little different. This one's my left arrow, but it's going up, which means to positive infinity, whereas this is my right arrow, and it is going down to negative infinity. Okay, so basically you were describing what the arrow is doing. So is the arrow going to positive infinity or to negative infinity? Okay, so I'm going to show you a couple examples of graphs, and then I will give you 2 examples at the end. Okay, so here are my 2 functions. So let's go ahead and write our statements. So just to describe end behavior. Again, that's what we're focusing on. To describe it, you would say as x goes to positive infinity, my function goes to. Now, what does it mean as x goes to positive infinity? It means I am going to read my right arrow, which is here. So where does my right arrow go? It goes to positive infinity. Okay, so I described the right one. Now let's go ahead and describe the left one. So as x goes to negative infinity, f of x goes to, well, again, this says to look at my left arrow. Well, my left arrow is over here, and notice it is going up to positive infinity. And there we go. All right, same thing to the next problem. Again, we're focusing on the end behavior. So as x goes to positive infinity, f of x goes to, okay, so what this is saying is take a look at my right arrow. My function is going, well, my right arrow is over here. And where is it going? It is going down. So how do I write down? Well, down means negative infinity, right? It's the direction it is going. All right, last one. So then I have to describe my left arrow. So as x goes to negative infinity, f of x goes to, okay, so again, my left arrow is over here. And notice it is going down. So this one's also going to negative infinity. Okay, so the first half of the statement describes the arrow. The second part of the statement describes the graph. So it says which arrow the graph goes which way. All right, so here are your two examples. Okay, so example number 1, example number 2. I will give you about 30 seconds to try it. Sorry about that. Okay, so let's start by describing our right arrow. So as x goes to positive infinity, the right arrow on this graph is going down. Now let's go over to this one. As x goes to positive infinity, that means my right arrow, this right arrow is going up. Okay, so that's the first half. Now let's describe the second half. As x goes to negative infinity, okay, so now this is telling you to describe the left arrow. Well, the left arrow on this function is going up. The left arrow on this function is going down. So here you go.